Okay, so in this video, we're going to be talking about rational functions, and we are going to be looking at equations of the form y is equal to a over x minus h plus k first. And when we have h and k, that is going to be mainly the center of the rational function. And most of the time, these equations are always going to look something like this, where we have a graph. And for example, if h is, let's just say h is equal to 1, then we're going to have an asymptote at x is equal to 1. And if k is equal to 2, then it's going to be shifted upwards by 2. And we're going to have a graph that looks something like this. That was a bad sketch, but and it's always going to have this type of shape since it is a rational function, or at its geometrical shape, it is a hyperbola since it has the same exact shape of a hyperbola, where hyperbolas are shaped like this. We have two parabolas shift looking away from each other. So I'm going to be referring to these as hyperbolas since that is their geometrical shape. So first we're going to look at the equation, or first we're going to go ahead and write an equation down. Y is equal to 3 over x plus 2. We're going to start with a relatively simple one without any horizontal shift. So we want to go ahead and graph it, and we're going to make a little graph. So now we want to go ahead and see if there's any asymptotes that we're going to have. And since we don't have h, we see that it's not going to be shifted anywhere to the left or right. So that means that our horizontal asymptote or our vertical asymptote is going to be x is equal to 0. So not 2, 0. And we're going to have so we're going to write vertical and horizontal asymptote at y is equal to 2. So we're going to make a few points here. 1, 2, and 3. -3, -2, and 1. Okay, so we have a small graph and we're going to plot our points given the rational function. So let's go ahead and look at when x is equal to 1, it's going to be positive 5, which is around up here. Or let's actually color it differently so we know. And when x is equal to 2, it's going to be 3 over 2 plus 2, which is the same thing as 7 over 3, which is 2.3. Oh, there's going to be 3.5, which is around here. And when x is equal to 3 is going to be 1, or 3 divided by 1. So that's going to be 3 plus 2 is going to give us, no, 3 divided by 3 is 1 plus 2 is going to give us exactly 3. So we can connect our points. giving us a shape that looks like this, and it looks to be shifted upwards. And we're going to go ahead and plot our negative x coordinates now. So we have negative 3 plus 2 is going to give us negative 1. And we're just going to it's basically a reflection of what we're doing. But now we have negative 3 over 2 plus 2, which is about 1/2. And when it is 3, we're going to get 1. So it should approach our horizontal asymptote slowly. Since we see that we are going to get a asymptote at x is equal to 2, or at y equals to 2, I meant. And it cannot cross the 0 or the y axis because then we'd be dividing by 0 and we cannot divide by 0. So that would give us a vertical asymptote at x is equal to 0, since this is where x is when it's equal to 0, and y as well. So that is our shape for our hyperbola. And we're going to go ahead and look at another one with a vertical shift and a horizontal shift as well. So we're going to have y is equal to 1 over x minus 1 minus 1. So we could write down what we are given. So we have we're just going to write it in simple terms where x cannot equal to positive 1, because if we go ahead and plug in x equals 1, it's going to give us 1 divided by 1 minus 1, which is indeed 1 over 0, which we cannot divide by. And we have a asymptote at y is equal to negative 1. So that means that we're going to have a line that basically restricts our hyperbola from crossing. And we're going to go ahead and graph it, giving us our horizontal asymptote at negative 1. So negative 1 is here. And we see that x cannot equal to 1. So we're going to make a dotted line as well here. So that basically tells us that here is our center of our hyperbola. And we're going to go ahead and graph our hyperbola now, our rational function. So let's go ahead and plug in x is equal to 0. We're going to get when x is equal to 0, so that's 1 over negative 1, which is equal to negative 1 minus 1, which is negative 2. So we're going to get negative 2. And now we're going to go ahead and look at x is equal to 2. So you have 1 over 2 minus 1 minus 1, which is going to give us 1 minus 1, which is equal to 0. So we're going to get that when x is equal to 2, y is equal to 2. So we see that we have two different points on different sides. And now we want to go ahead and look at a few more points so we could see if it is going to go up or if it's going to have a curve. So we'll see by plugging x is equal to 3, since this is 1, 2, 3, and -1, -2. So we're going to write -1, -2, and -3. So let's go look at when x is equal to 3. So we're going to get y is equal to 1 over 3 minus 1, which is 2. And we're going to get -1, which is going to give us minus 1/2 or -1/2, which is here. And then if we plot 1.5 or 3 over 2, we're going to get y is equal to 1 over 0.5, because 1.5 minus 1 is 0.5, and that is going to give us 2. So 2 minus 1 is going to give us +1. So we can see that our graph is going to look something like this. And from here, we could just basically make a rough sketch. It'll look something like this. So that's how we graph the rational function. So we're going to go ahead and look at a more detailed type of rational function. So we're going to go ahead and look at another example. So we're going to have y is equal to 2 over x squared plus 3x minus, well, actually plus 2. And we're going to have our little graph. And we are going to go ahead and see what's the asymptotes of this equation and to find where x cannot equal some number. We have to go ahead and solve the denominator first, giving us x squared plus 3x plus 2 is equal to 0. But in this example, we can go ahead and factor our equation out, since we see that we have two factors where x is equal to -1 and x is equal to -2. But we want to basically write it out in factored form, giving us to find two numbers that multiply to 2 and that add up to 3x. And these are the only two numbers that satisfy that condition. So now we're going to go ahead and make our asymptotes, given x cannot equal -2 and -1. So we'll go ahead and write that down. -2, -1, and we're going to make our lines so that we know it cannot cross this. So we're going to have a little area where there's going to be something here, but we don't know yet. And we can just go ahead and picture how it will look like, since we are guessing that it's going to look something like this. Or it could look something backwards or reversed, or it could look something like this as well. But that's how we could basically imagine our graph. Or it could also look something like this, but we don't know yet, so we can't really definitely say nothing yet. So we're going to make a few test points so that we can plot them. So there we go. So we're going to go ahead and make a table now on our left. And we're going to have x and y. So let's go ahead and write down our coordinates we have. -4, -3, -1.75, and -1.5, -1.25, 0, 1, 2, and 3. So we have quite the few values to plug in, but we're going to go ahead and see the easiest ones first, which is 0, 1, 2, and 3. So when x is equal to 0, we see that our quadratic is going to have a y value of 2, and 2 divided by 2 is going to be 1. So we're going to have a y value of 1 as well. So it goes here. And when x is equal to 2, we have 4 plus 6 plus 2, which is 12. And that's going to give us 2 divided by 12. And that's going to be the same thing as 1/6, 1 over 6, which is approximately 1.66 around there. So it's going to be around down here. And when x is equal to 3, we're going to have 9 plus 9 plus 2, which is going to give us 20. So we're going to have 2 divided by 20, which is the same thing as 1/10. And we know that 1/10 is basically about 0.1. So it's going to be here. And we have 1 over 6 and 1 over 10. And when x is equal to 0, we're going to have positive 2. It seems like I confused 1 with 0 earlier. But we know now that when x is equal to 0, y is equal to 1. And when 1 or x is equal to 1, we're going to get 1 plus 3 plus 2, which is going to give us 1/3, because we have 2 divided by 1 plus 3, which is 4, plus 2, which is 6. We know that is 1/3, so it is going to be here. So we can go ahead and erase that. And now we're going to go ahead and just sketch our graph now, since we see it's going to look something like this now. Let's go ahead and find what's here in the middle now, where we have this little closed bracket. So we're going to have negative 1.25, which is negative 5 over 4. And we're going to test that on our quadratic. So we get 25 over 16 minus 15 over 4 plus 2. And that is going to give us 25 over 16 minus 60 over 16 plus 32 over 16. We can go ahead and just add, giving us 32 plus 25 is going to give us 57. And minus 60 is equal to negative 3 over 16. And since we have 2 over negative 3 over 16, we can go ahead and see its value. So in order to do this, we're going to go ahead and convert this into multiplication. And by doing so, we're going to get 2 times 16 over 3, or negative 16 over 3, which is going to give us negative 32 over 3, which is like all the way down here, where it is equal to almost 11, 10.667. So we're going to have 10 up here, and that is going to be one of our values, and we want to see if it's going to shift upwards or downwards now. because we can't identify that with 1 point. So we're going to go ahead and test out negative 1.25, or we already did test out 1.25. So 1.25 is the same thing as negative 32 over 3. So we can go ahead and plot it there. And let's just erase all this now to make some space. So when x is equal to negative 3 over 2, we get 9 over 4 minus 9 over 2 plus 2, giving us 9 over 4 minus 18 over 4 plus 8 over 2. Thus, we're going to get it is equal to negative 1/4. And if we multiply 2 times negative 4, we're going to get negative 8. So it's going to be around here, negative 8. And here we see that we either get a shape that is going to go downwards or is going to go in a curve like this. So what do you think our shape's going to look like? So we get that it is negative 8. And now we're going to go look at negative 7 over 4. And we're just going to go ahead and quickly look for the solution. It is going to give us as well the same thing as negative 32 over 3. So we just write negative 32 over 3. So we see that it's going to go downwards now. So let's go ahead and make a rough sketch. And we see that the vertex is exactly negative 1.5. And we could also verify that that is the vertex, since if we go look at the quadratic and we use the formula for the vertex, which is equal to minus b over 2a, that is our vertex, which if we plug it in, we're going to get negative 3 over 2. So that is one way to see the first point, or the vertex, where we get this little circle where the U shape starts. Now we're going to go ahead and look at negative 3, which is 9 minus 9 plus 2. And we're going to get it is equal to 2. So we have 2 divided by 2, which is 1. So we're going to go ahead and plug that in. So when we have x is equal to negative 3, we have positive 1. And we can guess that our next answer is going to be 1/3, since we see that we have a pattern of 1. So we're going to go ahead and see if our y value is 1/3, because we see that every time we had, or the first time we had 1, the number that came after that was 1/3. So we can just assume. Let's go ahead and verify that. We have 16 minus 12 plus 2 is going to give us 6. And if we divide 2 divided by 6, we do indeed get 1/3. So that is how we can just see our next test point. So if we go ahead and look at negative 5, we're going to get 1 over 6. So we could just make that little assumption of a graph. So that's how our graph is going to look like. Since we were able to find the asymptotes, we were able to basically get a good idea of how our graph is going to look like, but we can't assume anything for sure yet. And now that is our example for this. And we're going to move on to a much more difficult one, where we're going to look at a cubic now. And the cubic we're going to look at is going to be, let's see, y is equal to, well, we're also going to have a linear factor at the top, x plus 1, and we're going to have a cubic of, let's see, of x cubed minus 7x minus 6. So it is equal, no, not equal to, and we may want to have a vertical shift, but I'll leave it like that for now. And we want to see if we could get a factor and cancel out the x plus 1. So we can go ahead and try to use 7, 6 minus 6. We can go ahead and see if we could try to factor this. And if we can't, then we're going to just say that there is no factor. And we'd have to look at the or the asymptotes where x cannot equal some number. Go ahead and use our synthetic division where we have plus or minus 1, comma plus or minus 2, comma plus or minus 3, and plus or minus 6. So we're also going to see how many positive solutions and negative solutions we could have. So let's go ahead and look at a specific or something interesting, which is Descartes' rule of signs. Minus 7x minus 6 is equal to 0. And you want to see the sign changes, and that'll tell us how many positive solutions we have. So we see that there is one sign change, and then there's 0 sign changes. So that gives us a small table, giving us one positive solution minus an imaginary. And to find the negative solutions, we're just going to set y or f of x equal to negative x, giving us negative x cubed plus 7x minus 6. And we're going to look at the sign changes where we have one sign change and another sign change. So we have two sign changes in total. And we have 0 complex solutions because they should add up to the highest degree, which is 3. And 1 plus 2 is equal to 3. So we don't really need to get another list. So now we can see that we have one positive solution. So let's go ahead and test out x is equal to negative 1. So we're going to make our divisor, and we're going to have our term we're dividing by, and we're going to have 1 x cubed plus 0x squared minus 7 and minus 6. So this should be in the form x cubed plus x squared plus x plus some number. And we're going to see if we could get our answer to be equal to 0 because our remainder should be 0, and that will tell us if it's a factor. So here we're going to go ahead and drop down 1. Just drop it straight down. Don't do nothing to it. Now we want to go ahead and multiply our number that we're dividing by and our number that we get. So 1 times 1 is equal to 1. And then we're going to add from bottom to top, giving us positive 1. And we're going to go ahead and multiply again, which is going to give us 1 again. And now we're going to add up downward, giving us negative 6 because negative 7 plus 1 is equal to negative 6. And we're going to go ahead and multiply by 1. It'll give us negative 6, which is negative 12, which is not our solution. So we can go ahead and just remove the plus 1 or the plus 1. And we're going to look at negative now. So we have negative 1 and our little cubic here, 0, negative 7, and negative 6. And just do the same thing, drop down our first number, multiply by the number we're dividing by, and we have -1, add, do it again, multiply this number with this, giving us +1 because -1 times -1 equals +1. And now we're going to add, giving us -6. Now multiply -6 by -1, and then we're going to have to place it up here. And we see that 6 minus 6 is equal to 0. So that gives us that we have a factor of x plus 1 times x squared minus x minus 6. And we could factor this out or use division. So we're going to see if we could factor this out. So we have to find a number that multiplies to -6 and adds to -1. And we could try to see those numbers are +3 and -2, since 3 times 2, or 3 times -2 is equal to -6, and 3 minus 2 is equal to +1. So we have to switch the sign of our answers, giving us x minus 3 and plus 2. So we get -6 again, and -3 plus 2 is equal to -1. So that is our factor. And we see that from our table, we have our solutions are x is equal to -1, comma, -2, and +3. And our table suggests that there are 2 negative solutions and only 1 positive solution, which is R3. So we don't need this table anymore, and we don't need this anymore here. So we can rewrite our entire equation again as x plus 1 divided by x plus 1 times x minus 3 times x plus 2. We can go ahead and cross out the x plus 1, leaving us with 1 divided by x minus 3 times x plus 2. And we're just going to use our quadratic. So we're just going to leave it like this, but we're going to use our quadratic to find values. So we're going to have x squared minus x minus 6. And we're going to make a graph now. And we're going to see the x solutions where they will not be true for our rational function, which are the x solutions to our cubic. So we're going to have x cannot equal to +3 and -2. So we're going to have a asymptote at here and at +3, which is more further around here. And we're just going to make a line. So now we're going to go ahead and make a table now on our far right of our x and y values. And it also seems we're going to need a little bit of more space for the right side. So we have a huge section in this little area, and we're probably going to have a graph like the previous one that goes from both sides and something that looks like this. So let's go ahead and see if that is true. So we're going to plug in, let's see, -3 and -4, -2, -1, 0, +1 and +2, and +4 and +5. So we're going to be testing a variety of points. So let's go ahead and write them down. Okay, so let's go ahead and look at 0 first. And when x is equal to 0, we're going to get -6. So it's going to be 1 over -6, which is going to give us -1 over 6 only. So we're going to have -1 over 6, which is around here. And when x is equal to 1, we're going to have 1 minus 1 minus 6, which is just going to be 1 over -6 again. So let's go ahead and put it here again. And so we're going to go ahead and look at -1. So giving us 1 plus 1 plus or minus 6, that is going to give us 8 or 2 minus 6, which is -4. So we get -1 over 4. So when x equals to -1, it is going to be -1/4. So we see that it's going to approach from the bottom and touch these 2 points, but we're going to go ahead and see what we get when x is equal to 2. So we have 4 minus 2 minus 6, giving us -4. So we're going to get the same point again. And it's going to have the same shape as its symmetry, since we see that if we just basically split this in half, the values are going to be the same. So now that is how our little rough sketch is going to look like. Now we're going to see what it looks like from the left and the right side. Let's go ahead and plug in 4. So when x is equal to 4, we have 16 minus 4 minus 6, which is just 6. So we have positive 1 over 6, which is up here. Positive 1 over 6. And when x is equal to 5, we're going to have 25 minus 5 minus 6. That's going to give us 14. That's going to be 1 over 14. 1 over 14 being close to 0. So we're just going to write or draw our rough sketch and then look at the left side now. So we could go ahead and just copy off the same points, negative or positive 1 over 6, 1 over 6, and 1 over 14. Let's go ahead and verify -3 first, see if it is positive 1 over 16. So we have 9 plus 3 minus 6. That is going to be -6. And no, that's going to be positive 6, I meant. And 1 over 6. When x is equal to -3, it's 1 over 6. So we don't need to look at -4. So we're just going to copy the same points. And we're going to get the shape looking like this. So that is how our rational function is going to look like, since it has every single x value tested already. And we were able to see if it has a little parabola looking shape in the middle where it goes straight downwards or upwards, and we were able to verify that it goes downwards by plugging in points. And it basically told us that we were able to cancel out the factor as well. Since if we were just to go ahead and graph this graph, it would look the same if we just plugged in values, but we wouldn't get the asymptotes unless we verified them by just testing points. So that's that for this example. We're going to look at one final one, and we'll see how looks like when we have a biquadratic function. Oh, what was that? And to get rid of this. Okay, so now we're going to look at one final one before we close the video, which is 1 over x to the power of 4 minus 2x squared plus 3. We're actually plus 1. So we're going to go ahead and solve this. Squared plus 1. And we could convert this into a quadratic by setting x to the power 4 equal to u squared, and x squared is equal to u. So we get u squared minus 2u plus 1, where we could easily factor this equation out, giving us u minus 1 times u minus 1, basically giving us a repeated solution. U is equal or u minus -1 squared. And we could go ahead and just plug in x for u now, giving us u is equal to x squared. So we have x squared minus 1 squared, giving us x is equal to plus or minus 1. So we're going to write in our equation that x cannot equal plus or minus 1. So we get 1 and -1. So we have -1 and +1. And we're going to go ahead and make a little table. But first, let's look at 0, or x is equal to 0, to see how our graph is going to behave. So we'll get when x is equal to 0, we have it is equal to 1, because 1 over 1 is just 1. And when it is equal to -0.5 and +0.5, we'll go ahead and see that it is equal to 1 divided by 1/2 to the power of 4, which is about 1 over 16, and minus 2 times 1/2 squared plus 1. It will look something like, or we're going to go ahead and find the solution first, 0.5625. We divide that, 625, giving us 1.778, which is around up here, and it's going to go for both of our points. So we're going to get a shape, or our little parabola, looking like this. And let's go ahead and plug in 2 and -2. So we're going to get, when x is equal to 2, we're going to go ahead and get 1 over 16 minus 16. No, that is going to be 8. Minus 8 plus 1. That's going to give us 1 over 9. So we have 1 over 9. And we also have the same thing here. And we're going to look at 3 to see how it's going to behave. So we have 1 over 81. minus 18 plus 1, giving us 82 minus 18 being 64. So we have 1 over 64, which is so close to 0. And we're going to get our rational function looking like this. And we can go ahead and verify that by going ahead on any graphing calculator and verifying our graph. But we could easily see that since we tested all our points, it is going to look something like this because we were able to see our points and even some decimals or fractions like 1/2 and negative 1/2. And that is basically that for this example. So thank you for watching, and I hope you liked the video and enjoy the rest of your day.